Professor Saurabh Verma sir, and HOD IT, Professor Vishal Pandey sir. Our HR, Niharika ma'am, dear participants, my faculty colleagues and students, we are happy to organize this faculty development program on machine learning and application using Python. This is a 5-day FDP where we will learn fundamentals of machine learning techniques and their applications. In these 5 days, we will also have hands-on experience on machine learning techniques through Python. We believe that this FDP will help the participants to learn basic of machine learning techniques, their applications and Python programming to their application and Python programming to implement them. We are fortunate to get a good panel of experts from IITs and IIITs. They have several years of experience in this domain, having published research papers in different international journals and conferences of repute. These distinguished teachers, with their immense knowledge and experience, will guide us through this faculty development program, providing valuable insights, practical guidance, and inspiring us to excel in the field of machine learning. I request our Dr. Khatri sir to address this event with his enlightening words about our institute. Sir, over to you.
A very good afternoon to all of you. It is a matter of great pride for all of us that Computer Science and Engineering Department of our college is leading and organizing this first 5-day FDP of this session, in which renowned professors from IIT, IIIT DM, and our college will be discussing and sharing the latest developments and achievements in the field of machine learning and applications. As we all know, that Digital India is a flagship program of the Government of India with a vision to transform India into a digitally empowered society and knowledge economy. The program was launched on 1st July 2015 by our Honorable Prime Minister Shri Narendra Modi ji. This program has three key visions areas, namely digital infrastructure as a core utility to every citizen, governance and services on demand, and digital empowerment of citizens. This vision of government can only come true by spreading the knowledge in this field by our faculty members. I am pleased to note that resource persons Dr. K. Satya Babu from IIT, IIIT Kannur, Dr. Shweta Jain and Dr. Arun Kumar from IIT Ropar, Mr. Abdul Atif Khan and Dr. S.K. Mohanty from IIIT DM Jabalpur, Dr. B. Patra from IIT BHU, and Professor Abhishek Singh from our college, Baradia Global Institute of Engineering Management, Jabalpur, will be enlightening and the participating faculty and students by their vast knowledge and experience in the field. I hope all of them will utilize this golden opportunity to gain and enhance their knowledge. I appreciate the efforts of Dr. Mamta Samal, the head HOD Professor Saurabh Sharma and Professor Vishal Paranjpe, and all the faculty members of their department for organizing this FDP. I wish a grand success of this FDP. Thank you. Jai Hind.
Mamta ma'am, you are muted. Mamta ma'am, you are muted. Mamta ma'am, can you hear me? Your mic is muted.
नहीं, मैंने अभिषेक सर ने म्यूट कर दिए थे, मैं भी कर रही हूँ सर। हेलो हेलो, कैन यू हियर मी सर?
Yes, ma'am.
Now I request
Yes, ma'am.
CSE Professor Saurabh Sharma sir to say a few words about our CSE and IT department.
Yeah, very good afternoon, everyone. I am delighted to welcome all the dignitaries, our subject expert professors from IITs, triple IITs, and participants from different states of India to this faculty development program on machine learning and application using Python. As the head of the Department of Computer Science and Engineering, it gives me a great pleasure to inaugurate this event and welcome you all on behalf of Bareilly Global Institute of Engineering and Management. Python and machine learning have transformed the field of computer science and have promoted advancement across the range of industries. The ability to control the power of Python and machine learning algorithm has become a critical skill for researchers, academicians, and professionals. This FDP aims to give you the information and ability you will need to stay on cutting edge of these quickly changing industries. During this FDP, we have focused a complete program that will take you from beginning to end the foundation of Python programming and gradually introduce you the concept of machine learning. We have gathered an excellent team of experts instructor who will guide you through hands-on session, case study, and interactive discussion. I encourage you all to actively participate, ask questions, and collaborate with subject expert. This FTP not only provides you theoretical knowledge, but also promotes a culture of practical application and critical thinking. I would like to express my sincere gratitude to all the resource persons who have kindly accepted our invitation to share their expertise with us. Your knowledge and experience will definitely enrich our understanding and ignite our passion for Python and machine learning. I also want to acknowledge the effort of organizing committee whose dedication and planning have made this event possible. At last but not the least, I would like to congratulate everyone for participating in this faculty development program. Over to you, ma'am.
Thank you very much, sir, for your words. Now I would like to thank our partner, Mr. Saurabh Badaria sir, for providing us all necessary support to organizing this FDP. I also like to thank our director, Dr. Khatri sir, for always encouraging us to organizing such programs. I also thank HOD CSE Professor Sharma and HOD IT Professor Vishal sir for extending all their support and encouragement. I also thank all my colleagues for their constant support whenever needed. Lots of thanks to all the experts for giving their valuable time for delivering lectures. Thank you all once again. It's my pleasure to introduce our first speaker, Dr. Koral Satyababu, who is currently working as an associate professor at IIIT DM Kurnool as an associate professor. Prior to that, he has completed his MTech and PhD from NIT Rourkela. His area of research are artificial intelligence, data science, social computing, etc. His current research interest also includes natural language processing, time series prediction, recommended system, privacy issues in local-based systems, sentiment analysis, emotion analysis, and big data issues. He has guided several PhD and master students in several domains. He has published more than 25 international journals and in around 37 international conferences of repute. He has been handling several research research projects from various government as well as private organizations. He has also been serving as an editor and reviewer of several international journals. I have certain his introduction through it. It can span over several pages. With this, now I request Dr. Satya Babu to take over the session. Hello. Hello.
All the participants are requested to wait. As soon as our keynote speaker are here, we'll start the session.
Wait for a while, he is joining. Wait for a while, he is joining.
Madam, I have joined. I have joined the meeting.
Okay,
Yes,
sir.
yes.
So I
Same here.
request Dr. Satya Babu to start his lecture. Up to you, sir.
Okay. Okay, madam. Okay. Thank you. Yeah, is my screen visible, madam?
Yes,
Yes,
it
sir.
is beautiful, sir.
Okay, fine. Thank you, madam. And uh, s- so I have 1.5 hour, right? Now?
Yes, sir.
Okay.
It's up to
Mm.
4 o'clock, sir.
Up to 4 o'clock. Okay, madam.
Yes, sir.
Okay. Fine, madam. Okay, thank you. Uh, so, to the audience, all are faculty members.
Faculty members and MTech students are also there. Research
Okay.
scholars are also there.
Okay, research scholars are also there. Okay, fine. Thank you, madam. Thank you for that briefings. So I'll be dealing with this lecture on introduction to machine learning. As this is the first lecture, so I'll be briefing about all the machine learning techniques, why we need to use this machine learning, basically what is the importance of this learning by the machine and its various application and allied areas. I'll just go through uh, in this session. So first of all, we have to understand why a machine should learn. If you just go through like uh, you see here, you have earlier the artificial intelligence, which we can say that artificially a person need or a machine should be able to acquire the intelligence, same like that of a human being. So if you see a human being, uh, like earlier the machines used to gather the intelligence using like some assumptions, or like you can say like some set of rules, built-in rules, the machine. But this this like machine was not able to acquire all the data and exhibit the sense of intelligence same like that of a human being. So they used heuristics later. So heuristics are like this human like thought processing activities, same like that of a how a human exhibit. using some shortcuts and all, some basic rules and all. They used to do it, but you know that there was ups and downs, the winters of AI and all were there, where there like the machine, however, could not learn and exhibit the intelligence. So then only the consortium of some like companies, or as such, like the consortium of some industries, they amalgamated few techniques like this fuzzy or neural networks. Everything came into picture, and then like this even the fields of data mining, the statistics, everything gathered together, and then they started uh, training a machine. But sufficient data was not there again. But with the increase in huge number of the huge computation speed of the late, now data also is gathered in a very potential way, and then the machine was being able to be trained. So we can say that like to some extent they used to exhibit a narrow intelligence, little bit of like a common man. The machine was able to exhibit the intelligence to some extent, like not like a complete the depth level of intelligence what a human being can exhibit it. So here the machine was fed with or like trained with the intelligence that is artificial in nature, right? So artificial intelligence, we say, is the ability of a computer program or a machine to think and learn. It is also a field of study that tries to make computers, as we called nowadays, the jargon word, smartness. So they work on their own without being encoded with commands, or without being used like giving the online commands, or we can say like an example. If you take it, a drone, for example, unmanned drone, for example, or uncrewed this aerial vehicle. If you see that one, like it has to be, or predator drones. Now of the late, very recently, our prime minister has gone to USA, and he has signed for to acquire some 9 drones, predator drones, to us, right, to the Indian, adding it to the Indian the armament. And if you see that one, like they are basically like unmanned. It means to say that uncrewed, and then like they are already trained, and they should be able to go, like given a particular target, they should be able to go there, hit the target, gather the intelligence, or do some surveillance activities. So all these type of activities, or if they are in swarm, then they have to have a proper communication understanding with one to one, like this, all the swarm drones, everything, and then return back. So all these, like given some minimal number of instructions at the very beginning, the system, or the completely the systems, the drones or the UUVs or UAVs should be able to go and work it out and fulfill the purpose with good performance, and then return back to the destined location which is given for. So you see here, they work on their own without being encoded with the commands, right? They, all these drones and all, they do as such. You see like this person called John McCarthy came up with the name artificial intelligence in 1955. These processes include, so what is this artificial intelligence? The process of gathering this artificial intelligence includes this learning. It means to say that the acquisition of information and rules for using of the information. Then it should be able to exhibit the reasoning, and it should be able to uh, perform the self correction activities. So if sufficient intelligence is given to this particular you see about a machine, it should be able to do self correction also. If there is any problem, suppose the target is given from a source to target, when a firing is taken place, and due to the movement of the earth, for example, the rocket is to be launched, or the satellite has to be launched to a particular orbit, and then that if due to the rotation or revolution of this earth positioning and all, suppose small deviation has taken a part, then they should be able to correct themselves, right? If it is if that system is equipped with this artificial intelligence, they should be able to it should be able to self correct the line of the travel of that particular satellite. So this is you can understand that, like, a system which is equipped with artificial intelligence can exhibit same like that of a human intelligence, but how this intelligence is acquired to a machine. So if a machine has to acquire that intelligence, it means to say that the machine also should learn. Not only simply, it is not like a set of what you will learn at the some point of time. Same like that of, if you see that, like the chat gpt, what it can do, it can, the machine has been trained, or the system has been trained up to some point of time, up to, for example, if it is 2020. So after 2020 something happens, the chat gpt may not be able to provide you the proper information about the uh, activities or the events or those labels of things that has happened, that has taken place after the training has been completed. So the system should be able to do all these activities, the learning, it should be able to do the reasoning activity, and it should be able to do the self correction activity. Now, building an intelligent system that transforms data into knowledge. If you see here, there is abundance of structured and unstructured data in the modern era. If you see, let me just go through, if I have that particular slide for you. No, I don't have here, but okay, let me tell you that, like, you see how much data is generated in a single minute. You let me just go through this, and then tell you. mm, Domo sapiens. You see, this data never sleeps 10.0 has already been released. If you just observe here, the previous year's data also is there. uh, Let me tell you, from 20 if you see here, data never sleeps through the years. If you see, let me see at that very basic uh, uh, starting point here for this particular website. If you see, uh, just see here once, how much data is being generated in a single minute. So in a single minute, how much data is being generated, I am just showing you here. Every minute of the day, when was this one taken? It was taken way back in 2013. This was, I think, 2013. Yes, we have seen that it is 2013. So first one was in 2013. If you see here, YouTube users upload 48 hours of new videos, and the mobile web receives 217 new users. So like this, if you see how much data is being generated, 2014, if you see YouTube users upload 72 hours of new video. Earlier, just in a 1 year period of time, you see 48 to 72 hours of video. And then in 2015, if you see, YouTube users upload 300 hours of new video. See, like that. Then afterwards, probably from 2016 and all, this YouTube, regarding YouTube and all, it is not given, but new statistics are come into picture like this. So you can just see that in 2016, 17 also, how much data is generated. And you see here, 2017, every minute of the day, assume that this what is this, you see Netflix, okay? This if you see the infographics, they stream, Netflix users stream 64,000 hours of video in a single minute. It means to say, in a day, how many hours is being streamed by different users, okay? And then by, in a week, in a month, or in a year, like that, how much data is being generated. So that's why huge amount of data is generated, right? If you see here, 2018 data is given here, 2019, 20, 21. So I think this data never sleeps. So 10.0 is there. It is the comparison is also given here. If you see here, YouTube users in 2013, 48 hours of video was being uploaded. YouTube users hours, YouTube that number of hours of video that is being uploaded, and you see in 2022 it is 500 hours. You see here also, Google users post a query onto the Google, in 2013 is 2 million queries, and now here in 2022 it is 5.9 million queries, almost 6 million. It's a 300 percentage of improvement if you see that one. Similarly, you see here Instagram photo shared in 2013 3.6 thousand, and here now in 22 you see 66,000. How many like you see the magnitude of change. Here also Twitter tweets shared 100,000. Here 347,000 tweets are being shared. Similarly, Facebook contents that are shared is 64,000 only in a minute, and then here it is 1.7 million in a minute. And email sent, of course there is not much change, but still you can observe that changes and all. It means that one thing that we have to understand is that uh, nowadays, due to multiple people, all everybody are getting savvy to the technology savvies only. Due to this, what happens is huge data is being generated. You go to a restaurant, you go to you go to a hotel, you go to any library, or you simply go roam on the street. Data is being generated from you automatically. They are capturing the video surveillance data. What is there available in the black box of a plane. So whenever a plane get crashed and all, we try to say that uh, we have to search for the black box. So the reason here is what they do is uh, everything gets stored in that black box. All the sensor data, all the video, everything that happens in a plane throughout that flight, from source to destination, everything is stored in a black box. So that's why, and in a single travel, how much data is being generated, it will be in terms of some terabytes. And if you see about that one, even uh, we have got this satellite data, or the space data. uh, uh, if you see the UK's space data that is being collected in every 30 minutes, it is amounting around you can say in a magnitude of terabytes only. The data is being stored. Very large scale synoptic telescope, large scale synaptic telescope that is available in UK, that is being the data that it generates, the telescope generates how much data. Huge volumes of data. You check about the weather data, the like climatic data and all, or the social media data. So data is generated in a very huge way. Yeah. uh, Somebody has a question, please, here, raised hand. Yeah. Yeah, sir.
Okay.
Yeah, please. Hello. Am I audible?
Yes, sir, you're audible. I think that was my mistake, sir. It was not
Oh,
question.
okay.
It's
Fine.
a
That's not an issue. Okay, fine. I saw some hand. That's why just I stopped it. Okay. Fine. So one thing we need to understand is that huge amount of data is being generated. So that is the source actually. So when that source is that much source of data is available, So you can say that, and moreover, you can understand that most of them are unstructured data today that is being generated. So machine learning emerges in the late 20th century as a subfield of artificial intelligence related to self-learning algorithms that extract and predict knowledge from data. So humans manually analyze large amounts of data to induce rules and make models, and machine learning can gradually improve predictive models and database decision making performance by extracting knowledge more efficiently with high performance from this data. So if you see here, uh, artificial intelligence field, you see 1950s onwards it is still there, and it is any technique which enables computer to mimic a human behavior is all those techniques are considered to be artificial intelligence techniques only. And 1950s, 60s, 70s and 80s comes this machine learning actually. And this machine learning, AI techniques that give computers the ability to learn without being explicitly programmed what to do, what not to do. The system should be able to do by itself. Then again in late 2011, 10, 11 and all, this deep learning architectures came into picture with the like ImageNet uh, competition, and that one using that designing the using the CNN convolution neural networks to identify the or recognize the object with a very less error rate. And you see here, so a subset of deep learning is a subset of machine learning which makes the computation of multi-layer neural networks more feasible and with high performance again. So you say about, when we speak about machine learning, we also should speak a little bit about the artificial intelligence. Why? Because why a machine should learn basically, and how much to learn, or as such to what level it can learn. So we have to understand something about deep learning also. So bidirectionally we need to have a surface level touch with artificial intelligence and deep learning. So machine learning, so one thing we need to understand as a thumb rule is that we need to train the machine, and the machine should be able to learn by itself. Now, if you see here the types of artificial intelligence is artificial narrow intelligence. We call this one as weak AI, and they do only particular functions of human, smart speakers. When we speak, they analyze the things and then retrieve the data and then they speak it out, like Alexa, Google assistant, or like Siri as such, or like you take it as a self-driving cars like this. Okay, so all these are narrow intelligence again, and this comes under weak AI. So an artificial intelligence that covers a specific functionality which humans can do, only some specific functionality only, not the functionality of complete functionalities of a human being. And majority of recent technological advancements have been occurred in these particular areas only, like specific areas. Of course we need to do like that only, that is the incremental research, that is always possible. We need to do like this, and then afterwards amalgamate all the specific areas to make a general area, or general intelligence, right? Now next one is the artificial general intelligence. We call this one as like the strong AI. So it should be able to do anything that a human should be able to do it. So an artificial intelligence that can perform all the activities which humans can perform, but still huge, a long way to go for this artificial general intelligence or explainable AI and all. And then technological advancement in this artificial general intelligence is relatively slower than this artificial narrow intelligence or the weak AI. So any application, anything that we take, we can take it and then get it trained, and then we can deploy it. May it be a self-driving car, may it be a drone, UAV, or a underwater vehicle also, or unmanned aerial vehicle, or like a smart speaker, or a smart electronic controller. Anything, any smart, anything that we call it as a smart today is a weak AI only. it ranging from different capabilities, okay, from either from the high level of capability on that particular area to a very low level of capability just by like using of a washing machine or as such little bit very small things. Okay, so you have this artificial intelligence, any technique which enables computer to mimic a human behavior. Then you have the machine learning, subset of AI techniques which use statistical methods to enable machines to improve with some experiences. And then you have the deep learning, which is a subset of machine learning which makes the computation of multi-layer neural networks feasible. And now we'll see about this machine learning. We'll enter into machine learning. So machine learning is regarded as a field of artificial intelligence and is the study of computing algorithms that automatically improve through examples and experiences. So when we see here some definitions given by some people, like Arthur Samuel in 1959, he gives that like this: a field of research that develops algorithms that allows machines to learn from data and execute actions that are not explicitly specified by the code. And another, like you see Tom Mitchell, that book is there on machine learning, right? A computer program is said to learn from experiences E with respect to some class of tasks T and performance measure P if its performance at tasks in T are measured by P improved with experience E. So if you see this one, like here the task T is suppose when we are taking some animals like this, dogs and cats like this, the task T is to classify dogs and cats, and the performance P represents the measure of classifying dogs and cats. E can be said to be the learning if the performance of classifying dogs and cats gradually improve through the experience, uh, or some data like assuming it to be like 10,000 photos or 60,000 photos, like as such, or the like samples, more the samples, better the way that the system can have learned. But we also have to see about like overfitting also should not be done on that. Now if you take a machine learning, various things that we study under this umbrella of machine learning, conventionally how a system learns, basically whether they use how they group the data, and then whether it is supervised, whether it is unsupervised, and then like or whether it is reinforced. Then you need to study about the algorithms and its complexity issues, and then like taken two machine learning algorithms to solve a particular problem, which algorithm basically is better compared to the other ones. Then you have got the deep learning activities which gives you like a in-depth learning of the system. Then you have a surface level study on the artificial intelligence, then on the data mining also, crunching of the data from huge volumes of data, how to extract like a valuable information again. Then as you said, like the classification we study, particularly like this classification regression, or like we study on this neural networks, we study on autonomous systems where like the machine learning is completely deployed. And for the analysis parts, or as such, in all this conventionally, if you see, we have a subject on all these peripheries of this machine learning, right? You see learning also we are having algorithms, deep learning, AI, data mining, classification, neural networks, autonomous systems, then analysis, then like how to improve or prediction or decision making activities. For everything we use this machine learning, right? Now uh, if you see the types and choices of machine learning based on data analysis, so if you see a machine learning workflow, so you have some data here like this. Initially some data is given here, then from this data you try to extract the features, what features are particular to a particular image here or a particular data item. Here we are taking images, so for a particular image. Now these features need to be trained to a machine learning model, right? We need to train it to a machine learning model. And now this using this machine learning model, when a new object comes, when a test data comes, assume it to be a cat, or dog, or as such, whenever the test data comes and being given as an input to this machine learning classification model, it should be able to identify, recognize, like whether this is a cat or dog or as such, like based on the training samples and all. But we need to understand two things that comes into picture. I think we have that in slides. We need to understand that sufficient data has been also used to train also. Okay, we'll see about that, like the challenges later. Now another one is like this machine learning versus deep learning. If you see this, like you have the data, this what the deep learning workflow, if you see here. So you see here in this picture images, you give us an input to a like from images you try to extract the feature. This feature extraction is not needed in deep learning, because the neural networks were originally inspired by the brain, but the details of how they work are almost completely unrelated to how biological brain works. So now you use give input to this neural network, and then try to train with different images or different data items. Then afterwards this pass through certain layers. Of course we have to do some intermediate steps and some mathematical activities you need to do it, and then you need to like given a image based on this feature set, extracting the features of the image automatically. Okay, these neurons basically they try to extract. They have like suppose this neuron is there, it may be specifically looking for something what it is capable of. So it will try to see or encroach the feature of this particular image uh, in that specialization or in that particular direction only. Suppose this neuron is only interested in finding about the horizontal line, so it will try to capture whether any horizontal lines are there available in this image or not. Whether next one, suppose it is interested in finding out the vertical lines, so it will try to find out. Okay, so like this different things which are of its region of interest, these neurons capture it and then pass it through. Again they give combinations, so the next level neurons make a different again combinations from combination of features from this the previous layer of neurons. Then as such it moves on forward like that, leading it to a single neuron, which is the output neuron, and then you try to predict it, like what is the percentage of that particular image object that it is available for in that particular test image. Now if you see the types and choices of machine learning based data analysis, there may be various criteria for classifying machine learning based data analysis techniques from various perspectives again. But in general, they are classified into supervised learning and self learning or unsupervised learning. So depending on the existence of objective variables or those response variables and the output target variables, so what it has to do, it keeps on doing it. So if you have a machine learning, so you have got unsupervised learning. Again, this unsupervised learning has got this dimensionality, may the other areas that are related with this unsupervised learning are dimensionality reduction, then like associations, finding out the patterns and associations, relationships, some clustering, okay, activities. Similarly, the reinforcement learning from the environment by that agents, and then like the supervised learning where you have for a discrete data or a continuous data you can do it, call it as a classification or a regression. Now the thing that we will see is on supervised learning. So supervised learning focuses on expressing the relationship between explanatory variables expressed as independent variables or features and objective variables which we express as response variables or dependent variables or target variables or the output variables, as well as predicting future observations. So it's mainly suitable for solving problems you can say like mostly see this classification or this deep learning first has got its exhibited its applications in image. So to a greater extent, like the recognition of the image, classification of the image, diagnosis of a particular feature in an image, and also the prediction. And the main techniques in supervised learning can be again like reclassified into classification and numerical prediction methods depending on the objective variable, and whether its explanation or prediction is numerical, may it be like a quantitative or a qualitative variable. The training data injected into the algorithm includes a desired answer, which we call it as a label again. Okay, so for every data that we take it, so label training set for spam classification, if you take it example of a supervised learning. So what we do it is like a suppose you every one of us has got our email IDs and all, and when we see in Google that email IDs, we can categorize that one, label it as a spam or non-spam email. And once you identify that one or categorize that one or label it as a spam email, then next time whenever we receive uh, particularly with respect to that particular content, or uh, from that particular email ID or from that particular source, it will be like categorizing it as a spam email, right? Even if it is the right email, but once you categorize it, then it gets, it is like you are doing it in a supervised way, right? It is a supervision. Using the supervision, you are trying to do this um, like a classification activities. So supervised, so you need to understand one thing, that this grouping of data, this both supervised and unsupervised are like these learnings, supervised and unsupervised learnings are basically conducted using grouping of the data. But one is with guided, as like supervised learning means with guidance, and another one is without guidance. If you take it, it is like small example. Let me try to give an analogy here. Like suppose we say that okay, I'm as teachers, we are, suppose I am we are trying to call to a small meeting for the students, and we designate individual places for them. Okay, this particular columns, column number 1 2 3, the first year students should sit, 4 5 6 the second year students should sit, 7 8 9 should be occupied by the third year students, and 10 11 12 should be occupied by the final year students. So it means that we are giving a designated place for them, right? We are giving like the data that is to be put there is like the model that we have already fit there, is like we are giving a supervised way of grouping the data, right? First year, second year, third year, fourth year, like that. Suppose let us say that we are not asking anybody to sit according to their groups or as such. Okay, like as per their year or the branch. What happens still, if you say like okay, we are inviting for a small kitty party outside in a tea bar, or like we are giving it in a like a tea time or somewhere like in a cave. Suppose we are inviting some students of a particular class. What happens is that they also keep on like suppose there is a multiple places to sit, like that students they sit as like they also form the groups, but this group forming is being done by the personal interest, right? The personal interest of the student. Like all the girls probably they will be sitting at one place, like that, and boys also of the same nature or category, or the same type of attitude and behavior category they will try to sit on a particular place again. So this way you can segregate, right? We can keep on segregating. We do not segregate it, but automatically the grouping is being done by the self of those students only. They do it by themselves. We are not doing it anything. We are not supervising that one. So this is what we call it as grouping of the data. either supervised or unsupervised grouping of the data. Okay, so supervised means a interference by the third party is there. Unsupervised means we do not have an interface by the third party here. Okay, so if you see now, let us see that. So you have a problem that is to be learned. So if it is, the sample is greater than 50,000 samples, for example, we have taken as a threshold as 50, but it can be more or less. Okay, it completely depends upon what type of problems that you are trying to solve it. Okay, what type of problems that we are trying to solve it. Now, if this 50k samples, uh, yes, the samples available is 50k, then you are trying to predict a category. If it is S and does it have a label, yes, then you go for classification activity. It means that if labeling is there, then yes, then you check if there are more than 50,000 samples. It means that like 100k samples are there. If it is S, then you go for linear support vector classifier. And then like still if it is not working, then go with, and if it is still a text data, if it is S, then you use naive Bayes. If it is no, then you use KNN classifier, k nearest neighbor classifier. Otherwise, still if it is not working, go with ensemble and support vector classifiers. And like uh, if the samples are less, then you go with the stochastic gradient descendant classifier, or with the kernel approximation. So see, this is not a hard and fast method that everyone need to follow. It completely depends upon what type of problem that we are taking, how many samples does it have, and what is the categorization of the data. So we need to understand that one. Okay, and if it doesn't have a labeled data, then it has to go for clustering activities. So number of categories is known. If it is known, then yes, then you divide it into like in each category this many samples are like suppose the data is 10k samples are there, then S means you use this k-means algorithm. Still not working, then you go for spectral or Gaussian mixer models like that, GMMs. Then like if it is less than 10,000 samples, no, then you create it as mini batch k-mean algorithms. Otherwise, like you go with the number of categories is known, then you do not know it. Sorry, you do not know it, and the samples are like if it is less than the given number of samples, still no, then you can go with some mean shift and VB mixer models. Okay, so similarly you see here, uh, if the predicting category is no, so you are trying to predict a quantity. If it is S, then you use regression for continuous data. Then like if it is no, then you are just uh, looking for the just data. Then still, so to look into the data or give an analysis, proper analysis of the data, probably you sometimes you may have to go with the dimensionality reduction activities, and like you go with the randomized principal component analysis. And if it is still not working and less than 10,000 samples, then uh, you can go for isomaps or spectral embedding or LLEs. And then like if it is no greater than 10k samples, then you can go for kernel approximation here also. So this is like what you have to do it. But please remember that this is not specific hard and fast, depending upon the problem, what problem that you are having, how much it is solved, and to what level you have to take it. That and completely it depends upon the nature of the problem. Depending upon the nature of the problem, suppose the sample size should be less or the sample size should be high for training, or even if you train any small sample set, that is sufficient. And whether all categories of the samples are there available, making it as a completely balanced data. If it is unbalanced data, again what type of activities that you need to take into consideration. So like this learning cheat sheet can be used for different activities. Now there are other types of learnings. If you see that one, you have a batch learning and online learning. So batch learning is that system cannot learn gradually, Means the system cannot learn gradually. And then online learning means the system is trained by sequentially injecting data one by one into a small batches called as mini batches. uh, so batch learning are basically uh, learning a little bit fast, but we need to see that it doesn't get under the problems of the overfitting or the underfitting problem. uh, so if you see processing large amount
Excuse
of
me,
data
sir.
yeah.
Sir, what is the main difference between the batch learning and the online learning?
Batch learning and online learning. See, what happens is that
I mean,
online
online learning.
yeah. I am audible, right? I am hello, I am audible.
Yes, sir, you are audible.
Okay, fine. So
Yes, sir.
generally what
Yes,
happens
sir,
is
you are
that
audible.
yeah, when we are trying to take a online learning, we cannot make it into batches. Online should be live. To a greater extent, it means that it should be continuous learning. See, suppose you just assume that let us assume that we are flying a drone and trying to with an eagle eye, means on the from the top of the sky, or like from the top of some buildings, we are trying to get some capture some data. And whatever is happening in a target area, for example one particular location, from one particular location we are trying to capture the data, we are trying to gather the data. So if like it should be like it has to take the complete data, it has to take it and live feed, it has to continuously, it has to keep on giving the data. So now that is online learning. Batch learning means what it does is that it collects the data, and after a specific period, or like some periodically, it will give you the period here is it may be large, depending upon the type of applications and what type of intelligence data that you are trying to retrieve. So it may be large. So when we take about batch learning, means at a time we give huge number of things and then try to learn. Incremental learning or online learning is like live learning. To a greater extent, we have the periodic learning is the like the time the time span for learning is very low. So if you bring keep into batches and learn immediately, the system may not be able to learn completely uh, in a single batch for a online learning, like that. So only thing, see, please don't get confused that batch learning means you are learning in a huge way to a greater extent, and online learning means live learning or incremental learning that you are doing in a short duration of time, slowly that one. I hope I am clear. If not, please we can go with some other analogies also. Am I clear, madam?
Yeah, it's clear, sir.
Yeah.
Yes, sir.
Okay.
Yes, sir.
Okay.
Thank you, sir.
Okay. Now you see about instance based learning. Mostly we learn about this one only. We study this one only, instance based versus model based learning. So instance based learning means the system learns by remembering training samples. So it is generalized by comparing new data and learning samples using similarity measurements. What I try to do is, for example, you have here some training samples are there. So when a new sample comes, I try to see like see the check the instances, other instances, and then I try to see that whether this particular instance, this new instance is like that of a this particular instance, means this new item that I have taken or new sample that I have taken is same like the does it have the similarity feature or dissimilarity with this item, or with this item, or with this item. So like that it checks for different instances, and based on the instances it tries to learn. And if you take it, for example, a small child learning. So in the very beginning, it is instance based learning only. Based on the instance, right? They learn that okay, uh, suppose like when they see that when a dog is barking very loudly, so they based on that instance they say that okay, dog barks, and then probably they should not go nearby that dog, or like as such they will based on some instances. So it means that whenever they see, probably that small child, whenever they see that dog again, because they remember that instance that okay, dog barks and it may bite, so they should not go nearby that one. So based on the instances they are going to learn. And if you take it a model based learning, the systems make a model from a samples and uses for its prediction. So you make it like a the what we do to a greater extent is this modeling only. So we train, right? Suppose we say that everybody have to come through this gate only and go through that gate. For example, in your institute, college, there are two gates. One is for entry gate, another is for exit gate. So the model has been built, right? That one has to enter from this gate and another has to, the exiting has to be done from that gate. So it means that if you are trying to come to institute there, you are entering from one gate, and if you are trying to go from the institute, it is like the other gate has to be used. Or the another example, if you see like this, like the teacher or the child has been taught with a model. Like see, suppose small like toys are there, toys are there of a tiger, cow, or like you take it as a tree, a plant, or like this. So based on that model, so if it is like this, it means that those all those models bringing together. See, like when a child is playing in the early ages and all, you must have known that if you ask that child to segregate based on the color, right? All the mangoes at one side, all the oranges at one side, or the bananas at one side and all. So it means that they are modeled. So this is that is using a model only. You are, suppose you keep it one mango or two mangoes at one place, one side, left side, two bananas at right side, and two oranges on the front side, and then you give one item to that child. Now you ask that child to place it onto either to oranges or this bananas, or like you try to give the another fruit and all, mangoes. Okay, so if you give a particular item based on the model of that particular item, then it will try to place it onto that particular group, right? So this is called model based learning. So the system makes a model from samples and uses it for prediction. uh, where to keep it, that one, right? So if it is instance based learning, means the system learns by remembering training samples. It is generalized by comparing new data and learned samples using similarity measurement. So what I say is that another analogy of this instance based, suppose I say that tomorrow, if you let us assume that there is a dog, for example, the dog is black in color. Okay, the dog is black in color, and you tell the child that this is a dog. And next day, you bring another black thing uh, with the same size, almost the similar size of that dog. The child will tell it is also a dog. It means that it is a model based learning. But if it is instance based learning, you have to say that incremental learning it has to do it also. Like how it does is like, first day you bring the dog, you show that this is the dog. Next day you bring the dog with a fur, for example, fur, and or with a different color. Okay, with a different color. So now the child thinks that this is not a dog because the color is different. But probably after analyzing some feature matching with that earlier seen dog, okay, so the child gets a incremental growth learning of inside the child's brain, stating that okay, these also dogs, and dogs also can exist not only in black but also it can be white. So the next day you take it another dog with brown color. So the child thinks that okay, if this is also a dog, then okay, dogs can be in multiple different colors, but they bark. So that is the common feature. Assume that all the dogs are have been barked in front of that child. So so this is the way the and And you suppose that all the dogs instance basically like they are very friendly with the children, so they are very nice, so the dogs play with the children and all, that is fine, the child feels very friendly. But assume that on the fourth day a dog comes and then it uh, using its nails or something, it hurts the baby. Then the baby thinks that okay, dogs are also a little bit harmful, right? So this is the way sometimes there is a complete shift depending upon the mentality of the child. But you can say that they get an assumption that okay, dogs are not only friendly but also they harm. So this is the way that like instances, based on every instance the child learns or the machine learns like that. Okay, now we say about the limitations of machine learning. So point number one is that data imbalance problem. Suppose the same thing, let us say that we have got uh, suppose we train a person with all three or four varieties of cars, okay, in India, for example, all the cars in India that person has drove he has he has to drive in all the roads of India, all terrain roads, hills, mountains, trekking roads, and then like plain roads, highways, state highways, national highways, everything it has been done very nice. But if the same person is again asked to drive probably in Europe or US, probably he will be little bit uh, may not be able to do it, because our driving style is that we keep our steering on the right side of the car, but probably it is on the left side, and they drive on we drive on left, they drive on right. So probably these are the things like how the because we are not trained with such system, we are not trained with such system, right? You understand that like suppose you everyone of you are now teachers, and so elderly people, and you have grown up people here. So you just assume that when the first time a like old man coming from a village and using a washroom, he doesn't know, he has never used a washroom, right? They must have never used a washroom, so they do not know. So slowly when you are acquainted with a system, then they will learn it. Or probably like when somebody comes from a village and they go to a shopping mall, probably sometimes they may go and hit on the mirror also. It's a like they may think that it is a through fare, means walk through fair, but it may not be, there may be a glass hindrance on that one, right? From one shop to another shop, or one from one compartment to another compartment, like that. So this is how if the reason here is that sufficient data was not there for them to get trained. That is the reason. Okay, sufficient data was not get there for them to train. So the earlier the data, all the sort of data is available, the best the model can be trained. So that is the same with all of us also. Suppose somebody do not know driving, okay, and you are almost above 35 or 40 years of age, then definitely he will not again try to drive again. Okay, he will never try to take a steering again. The reason is that he has not, he will have a fear, right? They have a fear. So with that fear, they will not be able to get uh, do that one. So the earlier the data is given, so suppose a person of ninth standard or 10th standard guy, or a high school guy, or a college guy just to entering into PUC or a BTech, if he is given an opportunity to drive, whatever may be the situation, let the car get hit somewhere, or let this guy get hurt, he doesn't bother, he takes the risk of learning, because learning is very high again at the early stages, right? So that's why one thing we need to understand is, if insufficient data is not available, or data, that we call it as a data imbalance problem, that is a conventional problem in a uh, learning like in machine learning basically, or learning systems. So most machine learning algorithms require a lot of data to work well. See what happens, we studied some things from our childhood down the line, 10 years, 15 years, 20 years, 30 years, like that we study few things and all. So everything is accumulated. everything is accumulated in our brain with a few things like which we remember. We have learned the system, we have learned the scenarios and all like that, right? If something is unlearned, sorry, if something is not learned due to the training samples, then definitely we'll not be able to cope up with that. So if the data, all types of data is there available, and then like and that is what we do also. Many of you, you understand that every one of us has cleared our college days, and then we have come to engineering, or have cleared the engineering and come to masters, or cleared the masters and done PhD, or cleared the PhD and done the if you see here, all types of, for an entrance test, for example, you are writing a 10th class examination. In the 10th class examination, the teacher, the mathematics teacher especially, tries to train you with all sorts of problems, all types of problems, right, to make you ready. It means that to train you, and then to make your system learned completely with all the types. So during the test phase and all, during the test phase, when a new problem comes, only you will feel that okay, this type of problem has been already solved by me. Only thing is that there is a data representation in a different way, and I need to just reanalyze it and re-represent it in some way, and then solve it. That one, it's fine. It will be very easy for you if you have already got trained with that particular problem. But if you have not got trained with such particular problem, it means that insufficient training was been done to you. Then when a new data comes which you have not ever solved that problem, then such type of questions will not be solved by you, right? Only thing is that it is left to the luck. So even in simple problems, thousands of data are needed, and millions of complex problems such as image or voice recognition may be needed. In the case you can't reuse a model that's already been made. You see, for example, some voice based systems and all, voice based systems, when you speak, you also speak the English, the Americans also speak English, Europeans also speak English, but where is the difference? The difference is that you understand, like the accent and all, we speak in a different way, right? So if that, see, when an American speaks, the machine basically understands, tries to understand, or it is to a greater extent they understands because of their accent. Europeans also in the same way. But when an Indian speaks, the machine may not be able to understand. It is mainly because sufficient data was not there to get it trained. Just a minute, I got a call once. Just 1 minute. So, and another thing is that, as I told you that there are winters of AI. uh, the learning algorithms are ready to a, means in 1990s the learning algorithms are ready, but data is not ready to get learned. It means that you do not have sufficient data to learn. So that's why, since collecting additional training data is not always easy or cheap, the algorithm cannot be ignored. So if you see that one, like a real database, if you see the MNIST database, if you see as a small dot here in a big set of space, consisting of, you generally like handwritten databases and all, right? The MNIST database, if you see like 60,000 samples it has got. From these 60,000 samples, you tell that okay, I have trained the system and my system will work. Now whatever I write it, the system will recognize. So this MNIST database basically is 60,000 samples collected from the school children for the numbers, right? Now how do you, only numbers do not exist. There are other things also. Handwritten means there are other things also exist, and also even numbers also, that is English numbers only, it is available. What about numbers written in Indian languages? or whatever the other characters in Indian languages, and you know that there are 1615 like 1650 or 1660 languages in India. And if everybody has got a character like that, of course every language do not have a character, and then some 23 or 25 languages have got a complete like a script also for that one. But assuming that all languages in the world, if you take it around something more than 200 languages will be there, because of 200 nations are there, it means, or 2010 210 nations are there, it means that there should be sufficient number of that many languages also exist to a minimally. So if you say that one like that, it comes with some statistics, 2 power 7 40 84 like samples. But we cannot say that training a administered database which is of 60,000, we cannot compare it that okay, we have trained the system, right? This says about the data imbalance problem in a greater way. This explains the like a very rare database in a vast space. We try to train only with the 60,000 samples or 1 million samples or 2 million samples, but will it be sufficient? Does it represent the complete field? My answer is no for that one, right? uh, so here it is again said that like the training data without representation. And if anybody is messaging, okay, uh, ఏమన్నారు? Okay. So training data without representation. So now what happens, there are different when you try to train so many so much data, sometimes the conventional machine learning, what they do is that they try to train sometimes what of the most of the researchers here in this group or MTech people, please remember that majority of the researchers, they do a minor training. I mean to say that they have a huge data set, and from that huge data set, they take a small sample and they train, and they say that, sir, we have trained the system with that database or that data set and all. You have to train it completely, taking it as 80-20 ratio or 70-30 ratio, or as such, you have to take do it, and also do cross validations. All these activities you have to do. Proper sampling also you should be able to do it. If you are not doing proper sampling, then how it may not represent the complete data again, right? So training data without representation, if it is there, there may be problems of sampling noise. So data without representation by chance means you probably you must have forgotten it, or sampling bias, where you say very large samples are not represented in, if the sampling method is wrong. Sometimes it happens like this. uh, and also it may be like it is basically because of the generality. You try to take it as a generality. Okay. Now another thing, limitations, if you say poor quality data. If you teach your child gali, then he will give that gali only language. If you teach good words, then that child will give good words only. So if you train a system with poor quality data, then the machine also functions with poor quality. So if the training data is full of errors, outliers and noise, the machine learning system will not work well, because it is difficult to find the inherent patterns. Realistically, the reality cannot be found out, right? So if cleaning is needed, if it is clear that some samples are outliers, it is better to ignore or fix them properly. And also there may be things that about irrelevant features. The system can only learn when the features and features related to the training data are sufficient. A key element of successful machine learning project is to do a good feature engineering. It means to identify the exact features. Of course, now you have got deep learning algorithms, and you are not much interested for the uh, like the feature extraction and all. It is not required to a greater extent, because the feature engineering is to a greater extent excluded. But in machine learning, conventional machine learning, this feature engineering also is a part and partial of that technology. So the feature selection, means like choosing the most useful feature among the characteristics you are losing. And feature extraction, combining features create more useful features, reducing the dimension. Of course, you have to reduce the, see, suppose I one example, I analogy, let me try to tell you. Is there any uh, gold medalist or award winners in the class topper? Best student award anybody has taken from this group? Best student award? Wow, great. There is somebody. I am teaching a best student. Very good. Uh, yeah. So Swati Soni has given a best student award. Very good. Used to be, sir. Okay. Very good. Very good. Now, no. Okay. Fine. It happens, man. In engineering, it happens. Okay. Because you are taken higher education. But see, getting a best award is not a great thing. But keeping it is a great thing. Okay. Every time getting that best is something great. So I tell my students always that getting a first rank in the class is not a great big job. Okay, you study hard for 2 days before the examinations, you just get a class topper. But every time getting a class topper means that is a difficult job. So anyway, that's not an issue. But you must have seen that this best student award is based on what are the things, what are the features they have taken into consideration to give you best student. Probably who got the award can at least respond to me.
It's class activities, other activities that I participated, the
Okay,
marks that I got in various classes. I was the
good, good,
topper of
good.
the class.
Okay, okay, good, 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 very good. I appreciate that one. Your name is, hello, your name is
Sir, my name is Zohaib Hassan. I'm a
Rohit.
faculty member. Zohaib. So it's
Zoe.
Zohaib.
Oh, great man, great, great. So you should be an inspiration to all the students in your institute. It's very nice, Zoeb. I appreciate it for that one. Okay, fine. Now Zoeb sir has got a best student award during his class days, college days, and all. So Zoeb sir has been given that award. The award parameters, what are the parameters? The institute probably took into consideration that Zoeb sir was always very regular to the class, always stood first in the class, and he used to be very like a very neat and clean. He used to time very punctually. He used to come to the classes. His attendance was probably the best. Everything was recorded, but there are other parameters probably not taken into consideration. Probably Zoeb sir, do you dance? Hello, Zoeb, do you dance? Do you sing? Or any other cultural activities you are good at? Zoeb is there online.
Yes, sir. Yes, sir.
So you dance,
No, sir, not at all.
you sing,
A little bit.
you do. You have any art craft like that? Any extraordinary talent, cultural talents?
Sir, I used to draw very good. I was a good sketch artist. I
Okay,
still
very good.
am.
Okay,
Yeah.
okay, good, good, good. I appreciate for all that you have, but I am taking you as an example here, analogy here. See,
Sure, sure.
Zoeb sir do not know dance, but he was given best student. Zoeb sir do not sing well. Means he sings little bit, probably, but he is given the best student. See, one thing what we need to take into consideration is that for a particular problem, we have to take uh, the feature engineering is very much here. Which features we are trying to take it, and which features are important. This is important for a particular person. If you take it, there are hundreds and thousands of parameters. The probably Zoeb sir was not given award for the height or the weight or the complexion of the skin, or for the hair he grows, or the stylish specs that he uses and all. All these things are not taken into consideration. This is what we call it as, we have hundreds and thousands of parameters, hundreds and thousands of parameters, but he was taken only the class topper, punctuality in the class, neatness, cleanliness, always is a fluency, asking whenever teacher asks a question, he always used to answer that question and all. So all these parameters main, so these are called which parameters are required. So the feature selection, so which parameters are required and which parameters are not required. See, probably I will tell you, in Zoeb sir's class only, probably there was a guy who is little bit shabby. He doesn't come very early to the class, but you know that early in the morning he cooks for his parents probably, and he does a part-time job, and then probably he earns his own food and comes means and even like for the living of his parents, old parents, or like for his sister, he earns something for the schoolings of a sister or the brother or younger brother or a elder brother, like that. And he does all type of activities at home, and then comes, but probably that is not recognized by a person, because the features are not important here. For a particular problem, which feature is more important, which feature is not more important, that has to be taken into consideration, right? So that is here. So that's the analogy, that's the example that I have given. But I congratulate you, Zoeb sir, congratulate, and you are an inspiration to all the students. Yes, yes, please, somebody raised a hand. Hmm.
Sir, I have a question. For
Yeah.
example, I'm referring to a research paper where they are doing some machine learning task and they
Yes.
have considered some XYZ features,
Parameters, features.
parameters.
Ah.
So, if I am referring that, and I also, is it necessary that I should also take that many features if I am comparing with it, or can
Yes,
I add
yes,
some
yes.
more
See,
things?
see, if you are comparing with that person with their work, you have to do it in that fashion only. That features everything, or at least top features. Their top features you have to take into consideration. Probably if they have done 10 features, you have to do at least what are the tape. You see, generally what happens is that those features, you know about this principal component analysis, right?
Yes, sir.
Or
Yes.
independent analysis and all. So what you have to do is that those particular features which comprise more than 90% of the problem has to be taken into consideration. It is not like 100% features are to be taken, but 90% of the 90% means you should not, it is not about the number of features, it is about the amount of that feature contributing for that particular problem, you have to take into consideration. And
And
it is always advisable when you are comparing with any standard articles, especially you have to compare with SCI articles only. And you please remember that you take, if you are comparing with them, take all their features, and if possible you take additional features also. That then there will be a they will consider that okay, this guy has done a better analysis than the earlier article, and also he has projected and they have shown in a nice way. So there is a the possibility of getting published will grow up. If you are doing less number of features than them, and if you are ignoring very the least principal components, then that is not a matter, but your work should be very highly standard then in that case, very very highly standard. So what I suggest is that always take their features, every feature of them, you take it and then try to experiment it. And you also have to experiment. See, many people what they do it is that this also one small mistake they do is that they take the features, they run their own machine, and then they say that okay, my system is doing better, my it is giving better performance. But did you run their algorithm? You have to run their algorithm also with that same set of features, and you on the same machine, and you also have to run your algorithm on the same machine, and then compare and contrast them, like where you are differing or where you are having a higher advantage over that existing algorithm. Okay, so this you have to do it anyway. This is about feature selection. I hope in a shortcut way I have cleared you.
yes, sir. Yes, sir. I got
Okay,
it.
thank you. So let me go back to this feature engineering. So here you see that irrelevant features, we need not take it, but we have to justify that which features are important and which features are not much important. That things have to be very much particular and peculiar. We should keep an eye on that one. Okay, uh, whenever we are doing, and these things are, that's why we call as a guide. Okay, a guide is a person who, uh, when you are taking as sir or madam, I am taking this many features, so we need to please settle down on some set of features. So these are the features, can I settle with this number of features? So there, those are the places where guide guides you. Okay, anyway, so another thing is that the problem of overfitting and then underfitting. Okay, so overfitting means you see that the putting constraints on the model to simplify the model and reduce the risk of overfitting. You can put constraints this one if you have to do regularization. See, overfitting, what we say is that exactly matching the data set. Suppose you train the system, then tomorrow when a nearness to that curve comes also, it will not accept it. What is underfitting? Selective. So underfitting means you are the system is not at all trained basically. Okay, the system is basically not trained. So in that scenario, what we need to do is that it means that you are not giving sufficient data, or you are not giving the complete all the iterations are not taken into consideration for training, or you are using some minimal number of iterations and all. So there should be a balance factor between this overfitting and underfitting. Always you need to consider this one. So in order, if there is overfitting of the data, you have to understand that you should put some constraints on the model to simplify the model and reduce the risk of overfitting. And if there is underfitting in the training data, then select a more powerful model with more parameters and provide better features in learning algorithms, and then reduce model constraint model constraints, so reduce the regularization of the hyperparameters. So you need to understand that there should not be overfitting or there should not be underfitting of the data. Okay, you have to keep in mind. So some applications also, just I'll go through some of the applications now. uh, First one, we will see about this predicting of this dynamic pricing or flight delay or stock market. Those things and all are dynamic pricing only, right? Those things and all, you can say that predictions. Okay, the flight delay, whether there will be a delay in the flight or not, or what will be the cost of a flight price, or cost of a steel and cement are also dynamic pricing only. Okay, same like that of a gold or diamond, right? Gold or silver. So the dynamic pricing and all. And in terms of travel, if you see, the predicting the flight delays or dynamic pricing of the ticket cost, those things can be taken into consideration as an application, and then machine learning can be deployed to see about the price of what would be the price of a flight ticket if I book on so and so date. Okay, and predicting the delay of a flight, how much delay it is. uh, mm, uh, okay. The next application is that in marketing, if you see about uh, like uh, predicting the lifetime value of a customer. Okay, whether this customer will, how much long he will uh, come, and how much, in what frequency he will come and do the purchases, or uh, can we do cross selling to this customer, or cross selling with different items, or can I do upselling, means apply some discounts, or reduce the discounts, or can I combine with some other items and do it, or can I do churn marketing, whom can I select properly. So like this, marketing also you can use, deploy your uh, this machine learning algorithms. But you need to understand, you see, one small example I tell you is, that some of you get messages in your mobile stating that for all the boys and all, a bike showroom is opened, or a new this something related to boys. If a girl or something is there, if a girl uh, uh, gets a message, probably a new garment shop is opened nearby, or a new gold store is opened in the city, or probably related to that. Okay, cosmetics, or a new brand of cosmetics is being into the market, like that. uh, or when a like for elderly people or somebody who is employed and all, they get like messages like plots to be sold or loans available. All these things and all are given. This is targeted marketing and all. You understand that why, how they do it? It is all machine learning based things. Okay. Now then, next thing, if you see about the health care, for the disease prediction, for the medication effectiveness, all these you can use your this machine learning algorithms. You know that, let me give you an example of swine flu and French flu. uh, uh, Swine flu is more dangerous than French flu, but the number of people who were killed or who died because of swine flu is very 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 high compared to swine flu. Swine flu is more dangerous actually, more dangerous, swine flu, uh, when compared with this French flu. Okay. It doesn't mean that it is dangerous, it is dangerous than COVID flu. This COVID is something different, but French flu and this swine flu, if you see, the reason why is that, see, any flu comes into the market, what we can do is that if the rate of spread, if we can calculate the rate of spread of a particular disease, then what happens is, we can control that disease. Because by the time the spread is taking place in a particular city, uh, if that person, like if the government's vaccines are available, if the vaccines are available in that city, then it can be controlled. But the problem here is that the rate of production of vaccines are very less, limited. So that's why, like, swine flu was not a though it was dangerous, but it was controlled in US basically, with because that time government took help from Google, asking that, like, so Google, what they used to do is that you know that the rate of production of vaccines are very limited. They are having limited vaccines, but to which city they have to send these vaccines? It is not like a capital city only you send it like that, no, but we have to send the vaccines in a very judicious way. So what Google did is that they did tracking of individuals of a particular city, means all the cities, basically all cities in US. Like if the number of parameters, see, you know that nowadays whenever we get some small disease, like you call it, I am flu with cough, what medicine should I take it? Or whether it, during COVID time also, every one of us has searched in internet, like, I'm having body ache, cold, fever and cold, whether it is COVID, symptoms of COVID, all these searches and all we make it, right? So in US also they do like that, so they did like that. And then, so when they found that, they have gathered, that if 127 parameters are searched in a particular city by a particular zone, then Google informed to the government that there is a possibility that the cases of swine flu may be reported immediately to the government. So government, what they did it, they immediately sent the vaccines, those particular vaccines, required vaccines to that particular cities. So when that, by the time the patient next day or another 1 or 2 days, they go and visit the primary health center there, or the medical unit there, they do the diagnosis, and as soon as the diagnosis is detected that there is a swine flu, then vaccine was already available, or like the corresponding medicine, retrofitting medicines was also available for that one. So that's why the spread of the disease was controlled to a greater extent, the swine flu. But French flu could not be done, because that time they didn't use any technology and all. The spread of flu took very vastly, and then it killed, I think, 1 million people and all like that. So in health analytics also, for this disease prediction and medication effectiveness, we can use this healthcare, uh, this machine learning algorithms in healthcare. So similarly, you see in social media, you know about the sentiment analysis, digital marketing and all. You see that you get an ad in for when you are watching a YouTube channel, you get a particular type of ad, right, based advertisement. The reason here is that already Big Brother knows you. It means that Google knows about you. And whatever you browse, whatever you track, you know that everyone, I believe that they are using an Android based phone to a greater extent. Okay, whether you used a iPhone also, still the iPhone does that one. Okay, then Apple will do it for you. If you are using a Android based, then Google will do it for you. The reason is here is that any Android based phone, or you take it as any phone, they are being tracked. Actually, they will be tracked wherever you go. The minimal data amount of data that is you see, like once upon a time an Australian, he wrote a mail to Facebook asking how much amount of my personal data is available with you. I think Facebook has replied with uh, some X number of some 80 GB, 90 GB of data has been given by Facebook. Then, out of curiosity, he has asked that, do you still have any other data other than the data with you? Facebook tells that, as per the policies of the company, again, other data cannot be revealed. It means that every data about us, when we are accessing it online, is available with one of the internet based companies only. I mean to say, like, may it be Google or any of the uh, companies, right, which I have taken the service, any company it may be. So this is the way. So you see about your Google Maps and all, or Google, you see about the timeline and all, which places you have visited, how many hours you have stayed there, uh, when did you return back. Your Google timeline decides, you tells you, gives you a complete report about that one, right? Then you know about the sentiment analysis and all. Suppose you write something about positive opinion, negative opinion, or like a neutral, what things means, whether you are how much you are for it or against it, or you are neutral, like that it shows. Also it studies again, like interior, if you go about sarcasm analysis and all, it does it for you, right? Then it also checks about the sales of the data, like what discounts I can offer and which season I can offer, and whether there is a demand for a particular like item or not. Then again I can see about this self-driving cars, pilotless aircrafts, drones, or like claims prediction for the credit and insurance purposes and all, the frauds and risk detection, the claim prediction, all these can be used for or all this has an application with machine learning. I hope I am clear with all these applications. um, can I move further? Hello.
Yes, sir. It's
Okay.
clear.
Okay, fine. So if you see about the applications in the image recognition area, the benchmark of ImageNet classification error rate fell from 26% in 2010 to almost 2%. And it is said that, like, the human has a error rate of 5%, but the machine has got reduced. This is all because of the usage of this very great machine learning algorithms, or conventional, you can say about the state of the art deep learning algorithms. So it was not until the adoption of convolutional neural networks that accurate of image recognition was dramatically improved. You see here 28% error rate, it seems, in 2010, 11 and all. 11, if you see, 26% it is. And AlexNet was a breakthrough with 16%, means a drastic reduction this is. Then you have ZFnet, then GoogleNet and VGGNet, then you have got ResNet, then GoogleNet version 4, uh, then like SENet. So like this, if you see, there is a drastic reduction in this error rate. So it means that when you are using it, because you know a CNN, or because you know a RNN, or a particular machine learning algorithm, you should not simply deploy it. Okay, you need to understand that whether really it has a application or not in that particular domain of your problem solving. Then only you use it. Okay, now for the image recognition, you can see, like, here, without even object, with the outlier, with the image segmentation also it can do it. you can do the classification and even localization of a face of a particular person or a particular animal also it can try to find out. Object detection, because multiple objects, see these are multiple objects, but still it will be able to detect it. Okay, this image recognition refers to technologies that identify places, logos, objects, people, buildings and other several variables in the image. Then computer vision and machine learning area you see in the marketing and all, like all the video surveillances or like it is there, and it will be useful for tracking. Then for the protection and security activities you use it. Then uh, using drones, there is a huge it is said that like this artificial intelligence and drone technology are a match made in tech heaven. It is somewhere I have gone through a technological article like that. So it means that there is a huge application of artificial intelligence or machine learning in drone technology, right? For scientific research you can use it. Deals with how computers can be made to gain high level understanding of this various, may it be a virus or a germ or any other activity or a particular disease. Okay, like that. uh, then then also you can use it like computer vision and machine learning can be used for this guided activities, then gauging, like a defect detection and packaging and inspection also, whatever the items that are being packed and all, or like if a chip is fabricated, is there any defect in that one or not, it can try to find out that one. uh, like you see so many things are given on the top also, like automatic inspection and analysis of such applications as automatic inspection, process control and robot guidance, that are basically used even in the industry and real life also, that is there. Okay, then like acquire automation using machine vision, a new area in fact. So acquire automation has a wide range of automated vision solutions that can ideally pack and verify a company's product quality at the level required by the government or a something like a regulatory body. So to identify whether it is like a valid one or invalid one. So basically the uh, acquire automation is a another great field, like how you can acquire data using different sensing technologies. Now you know the age of industry, people are speaking about 5.0, now 4.0 also is okay. It means that metaverse. Okay, people are speaking about the metaverse and all. So even my some of my students, three students have worked on this metaverse. They were working during their btech projects this year only. They were working a simulation of a supermarket, actually in a supermarket or a shopping mall. One was doing on a shopping mall, another one's a home automation, and another one was doing on a this supermarket like that. So you can see that metaverse things and all five industry 5.0 people are looking into. In that scenario, the acquire automation plays a very key role actually. Okay, uh, then you have about some applications of focal, where like some uh, this computer vision based stock detection system services can be given, and like how much data means how much stock is still available, or how much is to be replaced, those things and all, automatically it can give you a guidance, and then like a notification that okay, these items in the supermarket or a stall should be replaced immediately, or like to be placed again, because those are being sold away like that. If it reduces a particular filter level or a threshold level, then it notifies that one. So again, hello barbie application, you have seen about that hello barbie application and all. Like you ask and then it replies nowadays, mimicking. Even you can see about sophia robot and all they use this use level of machine learning algorithms. Then personetics assist, you see about this Google Assistant or Siri and all using mobile applications. I am just going through this one. Edge AI, another area, like how you can do you are running it on edge devices such as smartphones or a car or even a wearable device, instead of communicating with a central cloud or a server which provides the ability to process information locally and respond more quickly to some situations. These edge devices, if you can see this one, even swarm drones in defense, they have to communicate very fastly and within themselves. They cannot come to a base station and then the communication has to take place from base station, not nothing like that. They have to do it within themselves only. So this is the same way. Suppose two cars are moving each other, so the communication between those edge devices also should take place very quickly. Then the automation of vehicles, you see about, like first one is like a driver assistance, next one is partial automation. It means that you need not use your foot on the accelerator. That one, that is partial automation. Then automation level 3, if you see, like a conditional automation, so you can remove the hand from the steering. Then you can remove even next one is high automation, means even your eyes, you need not look into like where the car is going, everything you set everything and then automatically the car go. The fifth level or the last level, if you see, full automation, where your mind also is off. It means that you can sleep in the car and the car will take you to the destination. And this company Waymo by Google actually is hunting with this particular project. So if you see economics of machine learning, the innovation created by artificial intelligence started from software industry and will soon revolutionize all the other industries. So value created by AI, or as such the machine learning only, will reach $13 trillion by 2030. You see, so acquiring, enter into any business or anything without machine learning, it means that you are not doing uh, your it is same like you are simply you are not you can say that like you are uncivilized of computing. Okay, uh, you can say about that one only. It is equivalent to that only. So you need to know the basics of computing, the basics of machine learning. Nowadays this machine learning, artificial intelligence, IoT, drones, or as such, these technologies are not to computer science students only. It is to be everybody. All the students should learn that. It is a mandatory thing that everybody should know it. Little bit of machine learning, little bit of artificial intelligence, or this advanced technologies, IoT, drones, all this. So this is my lecture. Please, I am open for some more discussion, some more time, please.
Anybody having any question? Hello, am I audible to all?
Yeah, madam, you are audible to me.
Anybody is having any questions? Okay, sir, there will be no questions maybe.
Okay.
So thank you, sir, for your informative session. This session may be helpful to our participants. Your lecture clarity is very good. I think everybody will understand this lecture about the machine learning, how to apply the machine learning in different fields and all the things. And I would like to thank you on behalf of our organizations. And again, thank you for your time and for sharing your expertise with us. We hope you hope we we hope to have you have the opportunity to work with you again. Okay, thank you very much, sir.
Thank you, madam. Okay, madam. Okay, so can I sign off?
Yes, sir. Yes, sir. Thank you, sir.
Okay, okay, thank you.
Thanks a lot, sir.